Test rig, I will simplify the observation table and test rig. In this test rig, the main component is compressor, condenser, expansion device, evaporator, blower, fan and electric motor. First of all, the low pressure vapor coming from the evaporator having P1 pressure, T1 temperature enter into the compressor, where it get compressed up to the desired pressure. But that pressure is P2 and T2. The condition of the vapor is changed, that is the high pressure. The high pressure vapor. The high pressure vapor passing over this condenser tube where it rejects the heat due to air is blowing over this condenser tube. After that, T3 temperature, high pressure liquid. The high pressure liquid passing over this expansion device where it pressure and temperature both are decreases due to the throttling process. And after that, low pressure liquid coming from the expansion device which enter into the evaporator where it observe the heat from the fresh air, that temperature T5, and discharge at a conditioned air at temperature T6. These are the main component and observation table notation. Now this is the pH chart of R134A where this is the liquid saturation line, dry saturation line, T1 suction temperature, T2 discharge, T3 condenser, T4 is evaporator inlet, P1 pressure, suction pressure, P2 is discharge pressure. These are the point which we locate on the pH chart. Now let's move to the experimental setup. Good morning student, welcome to RAC lab. I am going to discuss window air conditioning test rig. As you know that it is works on vapor compression refrigeration system. Now I will discuss one by one component of window air conditioning test rig. The first is main switch for power supply, second voltmeter, this is the ampere meter for compressor, this is a temperature indicator. The temperature indicator show the various temperature inside the window air conditioner. So T1 is the suction temperature of compressor, T2 is discharge temperature of compressor outlet, T3 discharge temperature of condenser outlet, T4 is evaporator or coil surface temperature, T5 is air inlet or fresh air temperature, and T6 is air outlet condition temperature. Now we will check one by one these temperature. First is, this is the suction temperature, this is a discharge temperature, you can see, so it near about 66.2. This is the condenser outlet, so condenser outlet is near about 46-45, and this is the evaporator coil. The surface temperature of coil is 7.0, okay, and this is the air inlet temperature, T5 23.3, and this is the air at the outlet conditioned air which is passing over the evaporator coil, that is 16.7 degrees Celsius. This is the energy meter. It is used for to check the consumption of compressor. This is the discharge pressure outlet, suction pressure inlet. This is the rotameter to measure the refrigerant flow rate kilogram per minute. It near about 1.5 kilogram per minute, okay. This is the liquid line, and this is the capillary tube, and rest of the component like compressor, condenser and evaporator inside this cabin. Now moving to observation and calculation part of this experiment. These are the which we have noted down from the experimental setup. After that, open 134A pH chart, mark P1 and P2, the corresponding T1, T2, T3 and T4, and corresponding these temperature find out enthalpy H1, H2, H3 and H4, and after that putting into first equation, that is the coefficient of performance, that is equal to 4.32, and after that note down the temperature of fresh air and temperature of conditioned air by the thermometer, that is equal to dBT and WBT, and conditioned air dBT is equal to 21.5 and wet bulb temperature is equal to 20. These temperature mark on psychrometric chart and calculate specific humidity. The specific humidity give the dehumidification of the air, that is equal to W1 minus W2, that is equal to 0.05 kilogram per kilogram of dry air. And after that the cooling of air decrease in temperature 32 minus 21.5, that is equal to 10.5 degrees Celsius. And last one, the bypass factor of the cooling coil. The bypass factor of the cooling coil, that is, this is the T6 minus T coil upon T5 minus temperature of the coil, that is equal to 0.16 equivalent to 0.2. These are the resultant which we have calculated in this experiment.